The next stage started with laying out the cross slide on CAD. I chose linear bearings and ball screws for the motion. Linear bearings use a circulating ball train running on a hardened shaft, providing high accuracy and rigidity. Ball screws use a similar recirculating ball method for smooth operation and zero backlash. Connecting the stepper motor to the ball screw needed a bracket of some description. I sketched out the parts I had, the stepper motor on one side and the aluminium end bracket on the other. First thoughts were to fabricate some structure using metal parts and welding it up, but that seemed quite daunting. The square flange on the stepper motor had 4 mounting holes and a circular boss for location. The other side just needed a simple flat plate to the end. I decided to try printing a part using my 3D printer. Modeling the layout in a 3D CAD program with full-scale models of the bracket and motor helped to visualize the requirements. The yellow part is the final bracket joining the two parts. The other primitives are subtracted from the main body to form holes and openings as required. Each primitive is subtracted in turn until the final part is left. The next stage is to export the 3D model to a slicing program to construct and simulate the program required for the printer. You can simulate how each layer is printed by the 3D printer. Because there's an overhang at the top of the model, we required a bridge to support that. The bridge is discarded afterwards. And so the printing starts. The base plate is a piece of glass with a heater under it, heating that whole surface to about 60 degrees. The first layer has a skirt which helps to stick to that plate, and as each layer is printed, the head steps upwards about 0.15 millimeters. The whole process takes about 4 hours to print. The advantage is that if you don't get it right the first time, You can just discard it and print another. And another. And then eventually we got it right, but ran out of filament before the end. The final printed part, the support bridge is easily broken off and discarded, and hex nuts put into the little pockets to bolt onto the stepper motor.